do this. 2594, minimum time to repair cars. You give an array integer array ranks representing the ranks of some mechanics. Ranks of I. Ranks at I is the rank at the ith mechanic, okay? A mechanic with rank R can repair n cars in R times n squared minutes. Can repair n cars in R times n squared minutes. A mechanic with a rank R. Okay. You're given integer cars representing the total number of cars waiting in the garage to be repaired. Return the minimum time it takes to repair all the cars. Okay, so the ranks are 4, 3, 2, 1. The number of cars is 10. The first mechanic will repair 2 cars because you multiply for their rank by n squared, which is the number of cars, times 2. Can repair n cars. So the rank times n squared. So they repair 2 cars. It'd be 4 times 4. The second mechanic has the rank of 2 and repairs 2 cars as well. So it's going to be 2 times 2 squared, which is 8. Third one repairs 2 cars, so it's 3 times 2 times 2, which is 12. And the last one repairs 4 cars. If they were to, for instance, try to get the second rank dude to actually repair more, like 3, then that would be 2 times 3 times 3, which is 2 times 9, which is 18 minutes, which is an additional 10 minutes above this one, and like maybe they try to reduce this guy's load. That'd mean 4 times 1 times 1, which is 4 minutes, so they'd increase this guy by 10 minutes, and they decrease this one by 12 minutes. No? Oh, yeah, but you want to do the minimum of all the, it's not the sum of the minutes, it's just the minimum. So if this thing going to 18 would make the minimum 18 rather than, so you're optimizing for the minimum. Okay. Optimizing for the lowest, biggest number, lowest maximum, I guess. Okay. Wonder if you should do binary search again for this one. There's 100 ranks. So, alright, let's try binary search method. I'm not sure if that's the fastest, but it's a method. So we'll do for the binary search method, this is going to be try to try to search for optimal repair minutes. If using is possible to determine if possible to repair all cars under, let's say, X minutes. Let's say X is the variable there. If possible, then try for a lower amount. If not, try higher amount. Okay. So let's define the is possible method. let's go for X minutes. And this is just going to be the total amount of cars that is done when it's trying for this. So for each mechanic in the ranks, or I guess I'll say this, each rank in the ranks, we're going to see how many, so let's say X is like 100 minutes. Let's see how many cars that person can do in 100 minutes, depending on their rank, right? So the number of cars that they can do would be fixed will be equal to the number of minutes divided by the rank, and then take the square root and then like do the integer value of that. The square root, is that how you do? Python square root. I could do the exponential operator to the 1/2, but I guess this is fine. And technically, you add up to the total, and then return whether or not that total is greater than or equal to the number of cars that you are trying to fix. So the low amount, let's say right now, the low number of minutes that you try for is 1, and the high amount of minutes is well, let me think about this. So the low amount would be like if you, what is the lower bound? What would make sense for the lower bound? Like, yeah, let's just say 1 for now, and the high amount would be n has to be the low of all your ranks times, or the min of all your ranks. Like if you assign all of the cars to the lowest ranked person, that'd probably be the upper bound. The min of all your ranks times the number of cars squared. And then while low is less than high, you'll want to find what the mid is going to be. And then see if possible is it possible to do it with this amount of minutes, and if it is possible, then you want to try for a lower amount. So the lower amount means that your high is going to be smaller. High equals low, high equals mid, sorry. Else your low is going to be, else you need to increase your low. So you need to bump up how many minutes that you're using. Okay. So what would happen if you end up in, so in the end case, let's say the lowest eventually, so the mid works and you go less than the mid. Let's just say if it's possible to do whatever is the end value for the low, then I think that should be workable. Turn low, else you need to return low -1. If it's not possible to do it, and no, you return low +1. Is that right? If it's possible to do it in some number of minutes, you want to try for a lower amount. So you go down. But if it's not possible, then you go higher. Yeah, okay. I think this works. Low amount should be at least 1 minute. Yeah. Let me go ahead and just print out what was the low and high of these. So the low here, 1 minute. The least amount of minutes would be what? It's going to take at least 1 minute per car. At least. Right? Your rank cannot be lower than 1. So for instance, this one, yeah, the number of cars seems about a decent starting point. Maybe the number of cars times so each car should be 1 squared. There could be some slight optimization there. Okay, let's just see how this plays out. Is this fast enough? Wrong answer. Interesting. The number of cars is 21. And somehow you could do it in less than 21. Huh. How is that possible? So 1, 3, 1, 2, 1, 1. And you can do this in 18 minutes. So what would be the assignment here? The rank times n squared. Okay, let's see if it's actually lowest one. If that works. What the heck is going on? The method works, but I'm not sure why. If you have 18, you're trying to do 21 cars. Oh, I see. Yeah. Okay. Like technically, let's say the first one does 5, second one does 5. I'm thinking low is actually the total number of minutes, but this is just the minutes because it's happening simultaneously. It's not that. Can I do the low has to be at least the number of cars divided by the number of persons? Like let's say on average each person needs to do 3 cars. Then there's no way that each person needs to do at least 3 cars. Then even in the optimal case, each person needs to spend at least 3 minutes. I think that's fine. That's a solution, but not quite fast enough. How to optimize this? So this is a solution that is n log n for sure, where n is the number of ranks. N is the number of ranks. Return the minimum time to repair all cars. So is there maybe like a linear approach to it? So if we sort the ranks, perhaps so number cars, let's see, 1, 2, 3, 4. 1, 2, 3, 4. Maybe if you sort the ranks and then you what if you like did this ranks.sort, so it goes from low to high, and then when you check if it's possible, then you're looking at the biggest ones first. So total plus equals fixed. If totals is greater than equal to cars, return true. At that point you just return false. It does a little bit of short circuiting, so you never actually kind of use more than you need to. Okay, so that at least went slightly faster. Is there an optimization for the high? I think the low is kind of fine. The low is kind of fine. The minimum number of ranks, the min of all the ranks, doing all the cars. Maybe that's just a little too maybe that's a little too meh. Maybe it could be slightly better, because that's going to be a pretty big number. If you did the low amount, so if you did the average, each person does the average amount, kind of. I think that's going to be a smaller number, each person doing the average amount. So how would that work? It would be the highest rank doing the average amount of cars. Okay, so it'll be between lowest person doing all the cars or the highest person doing the average amount of cars. So max of all the ranks times not cars. So the average, I guess you need to do the upper math dot ceiling. Is it? I think it's math dot ceil. Okay. So it's the round up of each person cars by length of ranks. I don't know if this is all that. It seems like a pretty complicated calculation. I'm not sure if it's all much faster. Okay, the wrong high was introduced. So here I think the high was like 10. But why? Oh, I need to square this. Square root of this. So, okay. High 1. I'll say this is going to be for fastest does all cars. And this is the min of ranks times cars squared. And then high 2 is max of ranks times math.ceiling of cars divided by length of ranks squared. And this is each person does average amount of cars. And the high is actually going to be the lower of these two values. Okay, let's see how much faster this might be. Incremental improvements. Incremental. Someone did 9 milliseconds of this shit? Holy cow. How else could you do this? You immediately go for all the ranks, add up fixed is equal to dividing the number by the square root. Wonder if you can just do take the number divided by their rank, and then you do the square root of it. The low is going to be, you take all your, I guess you can do, like, if you've already sorted it, then you can just do, instead of min ranks, it'll just write ranks of 0. And instead of max ranks, it'll be just ranks of -1. Where -1 is the last index, or the index of the last element. Because that saves one more little bit of, didn't do very much. The low is going to be all the cars divided by, is that the low number of minutes? If, yeah, I guess if each person, there's 10 cars and there's 5 people, and each person does 2 cars, then you need to have that number of minutes. Yeah, I think that's correct. Let's see. If it's possible, then decrease the value. Otherwise, increase the value. I think maybe you just return high at the end. I don't know if you need to do a check at the end. Okay, yeah. is because high should always work. Um, low could pass it, high should always work. Okay, incremental. I think this is slight improvements. I don't know that you really need to do this calculation. I think you can just say high is high 1 or high is high 2. I don't see how using one person can ever really be all that great. So let's just try it with high 2. Alright, it's the same amount. Okay. In that case, I guess it doesn't really matter. I guess it's just like saving one calculation, really. Like an if statement. Not even if statement within a loop, it's just a freaking if statement. Total is 0 for ranks. For each rank in your ranks, divide that total by, divide that number of minutes by your rank, and take the square root of it. And take the integer value of that. I guess if you just did total plus equals this without doing an assignment. This is one less assignment each time. Very, very incremental improvement. Yeah. Each rank in your ranks. If your total is greater than equal to your number of cars, is there a way to to not do the if statement when it's far away? I wonder. So so you should never really what if, is there a way for you to tell that if your total is not increasing at all, your total should be increasing, right? There's no way that you're not increasing your total each time you do this calculation. So when you have ascending sorted ranks, is there a possibility where at the end of the array of ranks that at the end of the array of ranks that you don't increase your total because your number of minutes that you're trying is so small. Like you're trying for 50 minutes and your rank is like 100, so therefore you're not really getting anything. I don't think that's really reasonable. Probably not really testing it all that many times that you're doing that. What each rank ranks. Like if your rank is too big, if your rank is bigger than your number of minutes, then you're not going to increase your total. And you should just return at that point. Like if you did a check here where if x is greater than the rank, then just return false at that point. Greater than, because you're never going to be increasing your total after that. Does that work out? If x is greater than your rank, if your rank is greater than x. Yeah. I don't know if this speeds it up at all. Like this is an extra if statement each time. Yeah, that just slows it down. Yeah. How am I using more memory than other people for doing this? There's no way. Yeah. Like maybe I'm using high here. Where then you put the cars. I wonder if this thing actually helps to short circuit here. I think I did try it without this and it helped, right? So what if I just said return? No, I did. I'm pretty sure I tried it. Yeah. Okay. I think that's a wrap. Yeah. 90%, not bad. Or 90-ish%. So yeah, this is very similar to the previous ones. The time complexity for this one is going to be O of n for check if possible, because you're going to go through each element in your array. You're doing some calculation on the element, which is constant time, and then you return at the end if you go through all of the array or short circuit. But it's going to be at the end, if the array is n size, then you're going to go through each element. And O of log of n for this binary search. So overall, this is going to be O of n log n to find best number of minutes. And then space complexity is just going to be O of 1. There's no extra array that you're creating or anything.